Ladies and gentlemen, Mr. Hayes. Hey guys. Sorry I'm not there today. Thought I would go ahead and record this video for you. Walk you through the binomial distributions. You should have the notes from either by the door or by the sub giving them to you. Hopefully we'll walk through these and then you'll have some problems to go ahead and work on. So we're going to continue what we did yesterday with the introduction to binomial distributions. And then from there, continue fighting the good fight. And we're going to automate as much as we can today, and I'll show you how to do that in the calculator so your lives will be much, much simpler. So first of all, just kind of recoup from yesterday. There are 4 characteristics of the binomial setting. First one is each observation falls into one of two categories. It either works or it doesn't. So, and the success failure thing is just success is what you're looking for, failure is the other option. So male, female, voted, didn't vote, employed, unemployed, whatever. And the success is not necessarily the positive value of that, so whichever one you're looking for. There's a fixed number of observations like we talked about yesterday. So in this case, there's n observations. So you're saying what are the chances that it could happen? Like in the example we did was, you getting 6 questions on the quiz. Maybe you're picking 100 people. Maybe it's, 200 trials. What are the odds if you play the lottery every week of you winning? That type of thing. The n observations are all independent. So again, remember, knowing one thing doesn't affect the other. So, and that goes back to what we talked about first semester. And then lastly, the probability of success is the same for each observation. And that kind of ties hand in hand with things being independent. But again, it's one of those things where you don't want to say, sometimes even though things are independent, you might say the longer you wait, the more likely something happens. So, last thing, x is, whenever we're talking about this, the number of successes in x, or in n observations. So if we're saying the probability of x equals 5, that means that we're looking for 5 successes in however many observations that we have there. All right. Obviously, pause wherever you need to. I'm just going to kind of plow ahead, and you can obviously rewind, forward, whatever. So the actual binomial distribution itself falls into these characteristics. First of all, the binomial distribution of the count x successes in the binomial setting with, it is the distribution of the count of x successes in the binomial setting with parameters n and p. So again, n is the number of events that you're doing, and then p is the probability of that event being a success. So going back to what we did yesterday, n would be 6, because that's how many quiz questions that you're trying through. P would be probability of getting an answer right, which would be 1 out of 5. Oops, too big. N is the number of observations. Oh, look, I just said that. And P is the probability of success on any one observation. And then the last thing is X always has to be a number between 0 and N. You can't have more success than the number of observations. And you can't have fewer than 0 successes. Again, common sense. However, it needs to be said because otherwise somebody's going to assume that it can happen. And then what you end up doing is X is the binomial, this is saying right here, and since I don't have a pen here, I'm going to type this out. Let's pick red. So this is the binomial distribution with n observations and p probability. I think you could probably pick that up from what we said above, but sometimes I don't think we can over-explain things, So again, that's just kind of defining all the parameters of what we're going to do. And the next two things we're going to talk about are going to be important because it kind of lays the groundwork for A, what are we looking for? And then B, it's going to be helpful because that's what these two things are going to be what we're going to be looking for in our calculator. So PDFs. PDF stands for probability distribution function. And so it's for a discrete random variable x. The probability distribution function assigns a probability to each value of x. So what this is going to come up as then, let me make this a little bit bigger, and you don't care. But what this is saying is that it's the probability that x equals a number. Okay, it's not, so like, probability that x equals 5, that you have 5 exact successes. So this is going to be, let's do this maybe. So this focuses or deals with one possible outcome. So p equals 5. What's the probability that you have 5 successes? Not less than 5, not more than 5, not 5, 6, and 7 successes, just 5. Period. Done. This is contrasted with, boom, CDF. For a discrete random variable x, a cumulative distribution function of x is a probability of obtaining at most x successes in n trials. So what this looks like then is, this is where you start saying, okay, I will take, what's the probability of x being less than or equal to, to x, where x is being less than or equal to a number. I'm going to need to draw in the little line. And for those of you freaked out by this thing, let's change your color for you. Oops. There, you should like that a little bit better. So this would be, for example, you would take the probability of, actually here, let's see if I write it up. So this is the probability of getting up to and including a certain number of events. So as an example, let's say P is, what's the probability that x is less than or equal to 3, I would say 4. I don't need a little heart floating around, I want, there we go. It's ugly, sorry. So it means you want the probability of 4 or less successes. AKA, you've got the probability of 0 plus the probability of getting 1 plus the probability of getting 2, oops, plus the probability of getting 3 plus the probability of getting 4. And given what we were doing today, you would actually have to go through and calculate out each of those 5 different probabilities at the bottom. However, this is where our calculators are going to come in and save the day. All right. So the binomial coefficient, we talked about this in your notes yesterday. It's the number of ways of arranging k successes among n observations. Here's the formula for it. It's also known as just checking a subscript here. So n, choose k, for example. And that's what we were doing on the calculator underneath the math function yesterday. So n is the number of observations, k is how many successes that you're looking for. Because again, remember what ends up happening here is that you could essentially, let's say if we were talking about, back from what we did yesterday, with the 6 questions, you could get positive answer, you could get the correct answer, and then you might get a wrong answer, wrong answer, wrong answer, wrong answer, and then plus. So let's say we're talking about getting 2 right. So that'd be one option for what would happen. You could also get it so that you could get the 2 questions right first, right out of the box, and then 4 wrong answers. You could also get it so that you get the wrong answer, and then you get a right answer, and then you get a wrong answer, and you get a right answer, et cetera, et cetera. So, there's a lot of different ways to go through and arrange that. This will go through the binomial coefficient, and the combination setup here will go ahead and do that for you. And again, as a reminder, so over here on the calculator, define that. It's a little bit off my screen, but I think you can see everything, right? Yeah. So to do that, you would end up... I actually have to turn this on. That's weird. So you would go over to math, and you're going to go over to probability. And so before we do that, if I want to do this, you would go 6, math, probability, choose combinations, and then 2. And you hit enter. And so again, there are 15 different ways that the right answers could be arranged here. The 2 right answers could be chosen out of those 6. And that's where we're going to be coming from. So now, in practice, this is what this looks like. Let me zoom out here. So if x is a probability distribution of n observations, probability of p success, so same thing as before, this is what sets up. So if k is any one of these values, so in other words, k is the number of successes, when it says k is any one of these values, basically it's a number from 0 to n. You would end up saying that, okay, the probability that k happens is this part right here is the coefficient. So the first part is to use your binomial coefficient. And then the second number is the probability of success. And that's going to be raised up to the number of successes. Let's make this a little bit bigger. I'm just going to try to make it line up with everything, but it won't. Come on. Sometimes you wish I hit pause, right? And then you could multiply that by the number of failures, or the probability of failure. And then that's going to be raised to the number of failures that you have. And that's what and so this is basically, again, this goes here, this is here, this part's here. So what we did yesterday, remember, is we went through and we said, okay, so what is the probability of, going back to yesterday's example of, let's say we have 6 observations. Let's change the color for greens. So we have 6 observations, looking for 2 successes. So that means the probability of success, and the probability of success, I'm sorry, is going to equal 0.2. And so the setup for this then is you're going to go through, and so, I mean, technically what we're asking for is what's the probability of x equaling 2 and going back to how you'd write this out in terms of the binomial thing, we would say, oops, we would say, so we're looking for the binomial distribution of 2 comma 0.2 in this case. Now, in terms of setting all of this stuff up, what you're going to end up doing here, I think, equation. So the setup on this one, you're going to love this because you'll be able to keep up just fine. I won't be going too fast. Oops, I don't want a fraction there. I want, let's see. There we go. All right. So the first part is, so we've got 6 out of 2. So that's the first part. Probability here is going to be 0.2. I'm going to raise that to the third power, or 6 to be the second power, because we're looking for 2 successes. And then the probability, and remember, the 2 probabilities always have to add up to 1. And that's what this part's here saying. So whatever this probability is, you're going to go 1 minus that. So 0 minus 1.2, or excuse me, 1 minus 0.2, 0.8. And I'm going to raise that up to the fourth power. Now there's 2 very different ways that you could do it. Now, if we go back to the calculator, get back here. So if you're going through and do this, you could type this all out. So let's clear this out for a second. So you would type in 6 choose 2. Actually, technically, we should probably put that in parentheses to be safe. So 6 math probability choose 2, and then 0.2 raised to the second power times 0.4, 0.8 to the fourth power. And you hit enter, and you get the same number we got yesterday, 24.567. So this is going to equal 2.4. Okay. Now the other way that you can do this is this. Okay, there's this other option. And what you can do is, it's called the binomial. Remember, he had the PDF, probability distribution function. If you look on your calculator under distributions, you're going to see binomial if you scroll down PDF. And then when you do this, it's going to, when you choose this as an option, it's going to look for how many choices do you have, so how many elements are going on, how many events are happening. And then you're going to type in the parentheses, my big thumbs are getting in the way. And then K again is how many you're trying to do. So on your calculator here, to do that, hello. So you're going to go to distributions just like we did before. So remember how we had normal PDF and normal CDF. So we had normal PDF we used a lot. If you go, you can actually go around the world if you go up. I'm going to choose Binomial Pdf. And we're going to say, all right, oops, too much. And you're going to say, all right, I've got 6 events. And I've got a probability of 0.2. And I want to have 2 successes. Oops. And then you hit enter. Bam! There you go. Yay! Your life just got easier. You're welcome. And no, I wouldn't show this to you normally first, because you guys need to know some of the background of what's going on. So, as a couple of examples, let's try some. Hey! So for this one here, so again here, binomial distribution, we have 8 events, probability of success is 0.3. Okay, so just for clarity, binomial distribution, 8 events, probability of success equals 0.3. So probability of getting 5 successful, okay, if you're going to do this the old-fashioned way, so you go through and, type out whatever. So technically what's going on here again, come on, there we go. So again, for clarity's sake, so in this case we have 8 things going on and we want to choose 5 of them. And then from there, we've got, oops, let me do this actually. They just look nicer. So we got 0.3 going on, and we want 5 of those. So we're going to take that up to the 5th power because we want 5 successes. And then remember, if the probability of success is 0.7, or 0.3, that means the probability of failure is 0.7. And if I have 5 successes, that means that the remaining 3 would be failures. And you'd go ahead and type that in and go. The other way that we could go through and do this is that you could then go through and do your binomial Pdf. And then we're going to say, all right, we've got 8 events. We've got probability of 0.3, and then we want 5 successes. So when you do this and kick this all in, so again, this is saying that you want 5 exact successes. Not 4, not 6, 5. So again, kick through here, boom, and then 8.3, and 5. So 0.467. Oops, get back over here. Now down here, this right here is interesting because now notice here we talked about the cumulative one. And so cumulative means, so let's say if I've got, we could have 0 successes, 1 success, 2 successes, 3 successes, 4 successes, 5 successes, 6, 7, or 8. What you're looking for here is you want anything. Whoa, that's not what I want. So what you're doing, sorry, should have hit pause, no fill this round. You want any of those. You'll take 0, you'll take 1, you'll take 2, you'll take 3, you'll take 4, you take 5. Old days, you'd have to run this 5 times and get it. Or you'd run 6, 7, and 8, since that would be only 3 probabilities, and then subtract that from 1. However, in case you have not noticed, over here, if I go over here, you also have a binomial CDF. By the way, there is a Poisson and a geometric PDF, and those are different distributions that you can use. It's the same idea. You won't use them here. I'm just saying in the future, P is 1 exact probability, C is cumulative. So in that case here, we're going to go up and we're going to use the binomial cumulative distribution function. And it's basically set up the exact same way. And so again, same idea. We have 8 options. We've got 0.3, and then we want 5. Close it off. Just let me do in parentheses by the keyword. And so this would actually give us 98. So let's type that out here. So the binomial CDF 8, comma, 0.3, comma, 5 is equal to 0.988. Other things you're going to have to watch out for if they ask you for something like this, where x is less than 4. Since we're talking about discrete items, so it's like, the number less than 4 is 3. You don't have this 3.9 repeating thing. You've got to deal with this, then you're going to say, okay, this is the same as the p of an x value being less than or equal to, and I'm going to do this for sake of ease. P of x being less than or equal to 3. And that's what you would then go through and do. So you'd basically do the exact same thing up here. So then that would give you binomial. So you would actually run the binomial cumulative distribution function of 8, 0.3, and then you're going to say 3. And that number, if you run that, ends up being about 80, just over 80%. Okay. And I think that, as they say, is that. There should be some problem. I'm going to post some problems along with this for you to go through in Classroom so that you have an idea of what to do, and you can run a couple of these. But again, it's pretty straightforward, pretty formulaic, so hopefully that helps you get you set up for the starts of this, and we'll go a little bit more in depth tomorrow on some things. Thanks as always. Talk to you soon.